So I wanted to look at example 4 with you next. When you look at example 4, does anyone know what kind of a function this is called? This type of function has a name. Does anyone happen to know? That's right, Steph, it's piecewise. This is a piecewise defined function. So I want to talk a little bit about this with you. Okay. And I'm going to need a little bit more room to describe a piecewise function in general. So I'm going to go back to my other page of notes over here. And what I want to talk about a bit about is this idea of a piecewise defined function. Okay. Now the thing with a piecewise function is it's defined to be different function values on different pieces. So I want to show you with an example. So I am going to attempt to draw the United States here. So like this is the 49th parallel. And then, you know, here's the West Coast. And on here is the East Coast. This is Cape Cod right here. You come down here, here's Florida. Here's the Gulf of Mexico. Something goes on like this. This is the USA. Oh, there's Alaska too, right? So Alaska is over here. That's still the USA. And then maybe in red, I'll draw Canada. So Canada is like somewhere up here. All this other stuff here. This is Canada. Is anyone here from Canada? So we're going to define a new function. Our function f of x, this is called drinking age. Does anyone know how old you have to be in the United States in order to drink alcohol legally?
21.
21. So the output function is going to be 21 if x is inside the USA. That's the, I should say the word legal here, legal drinking age. Okay, 21 is right, Luis. So do my Canadians out there know what the legal drinking age in Canada is? Anyone from Canada? Am I the only one that live there in this class? No response. Oh, is it 18? I thought it was 19. We can Google. Or I can ask Siri. Hold on a second. What's the legal drinking age in Canada? Forget it. Siri never works for me. I'm pretty sure it's 19, 18. Oh, it depends on where you are from Canada. Okay, that's not good. Let's pretend that it's just 19 because I don't want to split it into even more pieces. But Jason, if we knew exactly which parts of Canada were 18, which parts of Canada were 19, then I could take my map and I could divide it into different, like more pieces. So this is going to be 19 if X is in Canada. So what have I done? I've taken the domain of North America. North America is our domain. I've divided it up into different pieces, namely USA and Canada. And then what I'm saying is the output of the function will be different depending on which piece you're on. So if you live in Canada, it's going to be 19. If you live in the US, it's going to be 21. If you live in Alaska, Alaska is part of the US, so that's still 21. So this would be a real life example of a piecewise function. Does this make sense to you all? Is there any questions about that? No. So if we go back to our sheet over here, what we're really doing is we're really taking the real number line and we're chopping it up into two pieces. We're kind of cutting it at the value of 2, right? And if the value of the function is less than 2, then your f of x is going to be equal to x plus 2. If your function value is, if your x value is greater than or equal to 2, then you're defining your f of x to be equal to x squared minus 4. So this is just a mathematical description of my drinking age real life example. Okay. So when we look at this example, they want us to evaluate one-sided limits for the function. And they say by plugging in points and by using a graph. Well, plugging in points, we'd use our calculator to see where this one's going and where this one's going. And then we'd see if we get the same numbers as we come from either side, just like we did for the sine x over x case. But what we want to do is I want to show you how to do it with a graph. Okay, so hold on one sec. Let me turn on the live transcript. So you can see the words at the bottom as I say them, hopefully. And I apologize to those students that tried to watch the video. I think the sound got all messed up. But if I turn on this live transcript, at least you can read what the words are supposed to be when you watch the video again. All right. So let's try to graph this. I'm going to put a set of axes over here. There's one axis. There's another axis like this. We're going to have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Well, that's -5 there. 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5 like this. It's -5. Okay. So I draw a set of axes like this. My first question for you is, what type of object is this one? In other words, for values of x that are less than 2, I really want to graph the function y is equal to x plus 2. And I'm asking you, what mathematical object is this? It's not a trick question. You can just tell me. Is it a parabola? Is it a trig function? It's a line. For sure, Audrey, it's a line, right? And you can tell me a couple properties of this line. Is this line, you can tell me what the slope is, right? What's the slope of the line? One. And I can tell that by looking at the coefficient of the x. So the coefficient for the x is a 1. That's why the slope is 1. And Aram brings up an interesting point. He looks at this plus 2 and he says this is the y-intercept. So the way he phrased it is he said we start at 2. I think of that as just the y-intercept. So I put a 2 over here like this, and then I'm going to draw a line. So this line kind of goes like this, right? And I should probably continue it, but only to 2. So I'm going to stop at about x equal to 2 right here. Because I'm only drawing the piece that's less than x equal to 2. So how do I express that this is less than and not less than or equal to? What should I put right here? Any thoughts? Should I put a closed circle or should I put an open circle? What do you think? Aram says open. What about the rest of you? Open or closed? Rocky says open. Joseph says open. Steph says open. Yahir says open. Wilson says open. Lewis, okay. You're right. Open. Open means we don't want to include 2. So we would need a closed circle when we do the second part over here, because that includes 2. All right. Now I want to talk a little bit about the second piece of our function. So the second piece of our function is going to look like y is equal to x squared minus 4. Okay. We know that we're going to have a parabola I'm going to draw our parabola first, and then I'm going to erase it. So we're going to start at 4. It's going to open up this way. So it goes like this. And then we have like this, right? But if you look at the left-hand side over here, this part fails the vertical line test repeatedly. This whole section over here is not a function because I've drawn too much curve. I got to erase all of this stuff right here because this function is only defined for x greater than or equal to 2. So what I'm going to do is I'm going to erase the left side. I'm even going to erase the right side and erase the point. I'm just going to continue my graph starting at 2, and then it comes up like this. But you can pretend that it was coming up like this, and then we erased the parts that weren't inside the domain x greater than 2, greater than or equal to 2. Does this make sense to everybody? So this is a piecewise defined function. And if you look, this picture is actually pretty similar to the classwork that we just did. I mean, it's very similar, right? You just a different parabola. This parabola is just shifted differently, but it's the same type of problem is what we're just doing here. So this is what we call an algebraic description of the picture. And the other one was a graphical description. Okay. So if you did want to create a table, this is what you would have to do. You'd want to calculate the limit as x approaches 2 from the negative side of f of x. And that would just be equal to the limit as x approaches 2 from the negative side of x plus 2. So what you would do is you would create a little table. You would have your x values here. You'd have x plus 2 over here. What would be the numbers that I'd plug in over here? Can someone type out some of the numbers I'd want to plug in the chat box? Or you can unmute yourself and just say. So Reagan, I agree, we're going towards 2, but what would you actually plug into a calculator? Would you plug in like 1, 2, 3, 4, 5? No. No, anyone know what I'm talking about? Like, do you see in this example, we started getting closer and closer to 0? So what would I want to put here? Getting closer and closer to 2 from the negative side. Any number below 2, negative 1.9. Ah, I'm glad I waited. So, Steph, I like negative 1.9. Leah, I'm glad you wrote what you did. What I want is I want a sequence of numbers that's closing in on 2. Like they have to get closer and closer to 2. So the numbers that you put in are sort of like numbers I've used to label a graph. What I really want to do is I really want to go like 1.9, 1.99, 1.999, 1.9999. Does that make sense? I want to get closer and closer to 2. I hope that makes sense to you, Leah. Let's take a look at what happens if I come from the right. So if I take the limit as x approaches 2 from the positive side. And now, if I'm coming from the positive side of 2, how do I describe my function? Well, positive side of 2 would be this x squared minus 4, right? So I'm going to put a x squared minus 4 there. And then when I create my table, I need to cook up some x values and the y values I'm going to get by plugging in x squared minus 4 like this. So just to make sure we understand what I'm saying, what numbers would we plug in over here? Someone just type in the chat box and then we can move on. That's right, Simon, exactly. 2 and above is right. Now, Reagan, we want to make it look like we're closing in on 2, not just random assortments, right? So I very much like Simon's answer. It's going to like 2.1, 2.01, 2.001, 2.0001. Let's pretend that we did that. If we pretended that we did that for both cases, what do you think the limit as we come from the negative side would be? What is this expression going to be? What do you think? Just type the answer in the chat box. Going this way. We're doing a one-sided limit, right? We're not doing two-sided. So two-sided limit coming this way. It's going to be 4. And then coming from the other direction, coming this way. This way, it's going to be 0, right? So I didn't want to use a calculator, plug all this stuff in. So I just used the graph to do it. Good, good stuff, good. All right. Okay, cool. So obviously students like working with the graph more than they like working with the piecewise function, but this piecewise function is a big deal for us. It's going to help us deal with absolute value functions, which is kind of important for this class. So this is just a preview for all that stuff.